Okay, we're ready to start our fourth video for preparing for exam 0. Okay, here we go. So let me just put the title as I usually do here, which is Math 108, Spring 21, Exam 0 review. And this one is D, I think, because it's our fourth. I believe so. Okay, so we're up to problem number 13. I'm very repetitive. I've told you it's out of 20. Here we go. It's sets again. C and D are subsets. They're even proper subsets, but we don't need that information right now. It's not pertinent to the problem of the universal set called, as usual, U. Okay, so here's what U has in it. Here's the universal set. It's got FKQ. It's got SXY. And it's got one more, Z. And that's it. That's in the entire universe. Now, what does C have? It's got SXZ. These are in roster form, as you can tell. This one, D, has FKS, right? They're supposed to be brackets. I don't even draw brackets very well, but obviously it's supposed to be brackets on both sides of the sets. Okay, now, first of all, write the answer. When we give our answers, the instructions are write answer in roster form. Okay, we're pretty used to roster form. That's how they want the answer. Don't forget, Alex has this bracket followed with box, followed by another bracket. That's the icon you use for roster form for Alex. Okay, so now, here is question number 1. Let's pull this up a little bit. Pull this up a little bit for complete clarity. Okay. Question A, 13A. As follows. What is C intersect D prime? Okay, fine. So let's go to scrap paper. Scrap paper. Let's first figure out what D prime is. Well, D prime is everything in the universal set that's not D. All right, this is supposed to be D. Don't get mixed up with my lousy handwriting, etc. That is D. Okay, D prime. Well, don't take the F. Don't take the F because it's in D. Don't take the K because it's in D. And don't take the S because it's in D, but take everything else. Take the Q, take the X, take the Y, and take the Z. That's D prime. Okay, fine. Now we want C intersect. We want C intersect D prime. Everything that is in both C and in D prime. Okay, so here's the answer. Here's the answer to question A. So everything that's in C and in D prime. Well, is S in both? No. Is X in both? Yes. Is Z in both? Yes. And that's it. That's the answer. Finished. X and Z. Question 2, or 13B, rather. How about parentheses, C union D, close parentheses, prime? Okay, scrap paper again. What is C union D? What about that set? Let's first figure that out. That set out. Let's first figure out that set. All right, we'll take you if you're in C or if you're in D. We'll take you either way. All right, so S belongs there. It happens to be in C and D. So X will take because it's in C. Z will take because it's in C. F will take because it's in D. And K will take because it's in D. And S we already did. So there's the set C union D. All right, compare C union D. It's prime, right? We're looking for prime. So compare C union D with the universal set and take everything that's in the universal set that's not in C union D. Okay, is F in C union D? Yes, forget it. We can't take it. Is K in C union D? Yes, it's in there. Can't take it. What about Q? Q's not in C union D. We'll take it. What about S? Is S in C union D? It is, so we can't take it. Forget it. What about X? X is in C union D. Forget it. What about Y? Y is not in C union D, so we'll take it. And the last one, Z, is in C union D, so we won't take it. So the final answer for this one is Q and Y for 13B and X and Z for 13A. This stuff is over. Problem 13 is over. Let's go to a brand new clean page for 14. Okay, here we go. Problem number 14. Let's get that up there, 14. And 2x minus 3y is 18. That's our equation. Let me explain in a second what we want. Is equal to 18. The question is find x and y intercepts and use it to graph. And use them to graph the line. There we go. Those are the instructions. All right, let's do our famous tic-tac-toe story. And we'll get the x and y intercepts as we explained in class. Right, so our tic-tac-toe little chart there. Now, let's try if x is 0. This is scrap paper. If x is 0, what is y? Well, the 2 times 0 is gone. Minus 3y is equal to 18. Negative 3, divide by negative 3 left, divide by negative 3 right. And you get then let me just go this way, laterally. And we get y is equal to, positive divided by negative is negative. So it's 18 divided by 3. It's negative, by negative 3, it's negative 6. Fill in the blank over here. If x is 0, then y is negative 6. Okay, first piece of scrap paper. Now, what if y is 0? What is x? So 2x minus 3 times 0 equals 18. 3 times 0 doesn't do anything. It's gone. Forget it. And cross it out just like we crossed this one out. So we have 2x is equal to 18. That minus is part of that. We don't need it. Divide by 2 on left and divide by 2 on right. And moving from left to right, I have x is equal to, just plain x is equal to 18 divided by 2, which is 9. So if y is 0, x is y. So here's our y-intercept. Y-intercept is 0, negative 6. And they may just want this. They may just, Alex might just want the negative 6. It probably does. Doesn't really care about the 0 many times. The x-intercept, we'll write it fully for the moment, is 9, 0. And Alex might just want you to say 9. Okay, what about the graph? All right, let's plot these 2 points, 0, negative 6. So in Alex, you will plot the icon will look like this to plot your points. That one, you click on that, and then you take it over to the point where you want it to be. 0, negative 6 is down here. 1, 2, 3, 4, 5, 6. 0, negative 6. You click on it. Using the site after you get to the point, click on it, and then 9, 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Click on that, and then it'll automatically draw the line for you. What we did in class is we label stuff. That's the y-axis, that's the x-axis, and here's the line called, I don't think Alex will be doing this, but just to keep consistent with what we did in class, we labeled things, and that's the label of this line. And that's it for problem number 14. Let's go to a fresh piece of paper. I don't want to take any chances of having not enough room for no good reason. Okay, fresh piece of paper. Problem number 15. Problem number 15. Here we go. And what does it say on your paper? If it says anything, it says solve You got y plus 4. This is a problem. Y plus 4 over 8. Sorry, 1 second. Equals 5 over 7. Obviously, they want us to find y. This is a proportion. This is cross multiply territory, right? A proportion cross multiply will do it. So the top on the left times the bottom on the right. Don't put the 7 to the right. Keep it in front. Y, 7 times y plus 4. That's that multiplication. And this multiplication, bottom left times top right, 8 times 5 is 40. This becomes, distribute the 7 across the parentheses. You have 7y plus 28 equals 40. We're looking for y. Minus 28 left, minus 28 right. This is gone. 7y is equal to 40 minus 28, which is 12. Divide by 7 left, divide by 7 right, and you get y is equal to 12 sevenths. What's on the, what does Alex want? Alex, I believe, is going to want you to click on the one that has a number and a fraction. One number and a fraction, because 12 over 7 is equal to 1 and 5 sevenths. 12 minus 7, 12 minus 7 sevenths is 1, and 12 minus 7 is, so there's 5 left. 12 minus 7, I'm sorry, is 5. So you have the 7 sevenths is 1, and then it's 1 and 5 sevenths. So you would put your 1 in here, and you would put your 5 in here, and your 7 here. And that's how you would tell Alex what your answer is. I believe that's what Alex wants from you. Okay, that's number 15. Let's go to a clean sheet of paper for problem number 16. Some of these take up some room, and there's no use fighting that. Just get a clean piece of paper, and it takes care of the problem. Here comes problem number 16. Okay, what have you got? The following story. You've got a box. This looks like sets, right? That would be our universal set, so to speak. Not more than so to speak. Then you got a circle in here, and they call it the green line stations. Green line stations, something to do with like subway stations or whatever, train stations. Okay, and then you've got another circle, another balloon or circle, and this is the orange line. Orange line stations. I'll just write orange line. That might be all that we need. So there's an N, some city or some stop, subway stop, whatever. Let's just call it N. And then another stop called O, and another one called V, and another one called M. Then 3 more. There's a C. I'm sorry. Oh, well, it doesn't really matter. Let's call it L. Let's call it L. It doesn't really matter. R. As long as they're unique names, we don't want any repetition. L, R, and Y. Okay. And then one outside the circles, but inside the box. 2 of them, I'm sorry. 2 of them. One is a U and one is a W. Okay? Here's question. 3 questions. A. How many along the orange line? How many along, the reason why they're using the word along is along the line, meaning the train station line or the subway line. Along orange line. Okay, answer is 1, 2, 3, 4, 5, 6. B. How many for the green end? How many along green and orange? All right, so it'll take you if you're in green or if you're in orange. All right, so that's 1, 2, 3, 4, 5, 6, 7. And finally, which are neither? Which are neither? The answer to that is U and W. They're neither, they're outside. We got to end this thing. Problem 16 is over. We're done.